As a kid, I always wondered about the changing of leaves. The greens to reds, the transition from spring to autumn. I have very vivid recollections of asking my teachers during science classes in 4th and 5th grade, how did the leaves change colors? And I always got elementary school answers. It's what they do in fall. No, but how? They change from green to orange. No, but how? I never got my answer, but I have continued to wonder about it. My whole life, it feels like. This assignment finally gave me the opportunity to feed a curiosity that I've always had. It starts on the cellular level. All plant cells have a cell wall, a vacuole, and chloroplasts. Chloroplasts are a type of plastid, an organelle that stores pigments and compounds. And what makes the chloroplast so special is that it's the plastid that makes photosynthesis possible. Photosynthesis is the process a plant uses to convert light energy into chemical energy. The chloroplasts do most of the work in this process by taking the photons of light and converting them into energy. And as for the pigments stored in the chloroplasts, chlorophyll is the boldest. Chlorophyll is present in all plant life. It's what gives leaves, stems, and algae its definable green. In fact, chlorophyll is so overwhelmingly green that all other pigments are drowned out by it. Because of chlorophyll's overwhelming abilities on plant color, there are several colorful pigments that we don't get to see as often that make flowers, fruits, and the season of fall so beautiful. One of these pigments, and I'm probably going to butcher the pronunciation of it, anthocyanin, makes the deep blues, reds, and purples possible. Carotenoids are the pigments that make plants yellow and orange. These pigments are always present in the chloroplasts, but can only be seen in blossoms, flowers, and specific seasons because of chlorophyll. So why fall? Why do we suddenly get to see carotenoids in October? Well, chlorophyll happens to have an exponential decay in presence as a growth season goes on. So the change of weather, the sudden decrease in sunlight, the temperature change, all tells chlorophyll to slow down from its original speed of production. That's why young leaves are so bright green. Their chlorophyll concentrations are super duper high. So new plant cells have a ton of chlorophyll, and as the cell lives longer and longer and we get further and further away from spring, the bold mask of chlorophyll's green begins to fade away. Only then, when there's less and less chlorophyll presence in the chloroplasts, all of the red, orange, yellow, purple colored pigments can show. Well, this is all fine and dandy. Plant cells have different pigments, and we get to see their colors seasonally, but why? It has to do with photosynthesis, apparently. Remember how plants soak in sunlight to create energy? Plants are actually super duper strategic. Light is measured by wavelength on a spectrum, which was discovered and created by, you probably know him, Sir Isaac Newton in the 17th century. Newton discovered that a light prism can reflect several different colors of light. Newton he's a pretty famous astronomer, math whiz, physicist, philosopher, so he's probably been given most of the credit for this. There are actually a ton of scientists that help in the discovery of this light spectrum that, as we know it today. Newton only wrote up the findings for optical light, the light that we get to see. William Herschel discovered infrared light in the 18th century, the light that we can't see. And just to throw in another name and prove my point, Johann Wilhelm Ritter identified ultraviolet light in the 19th century, which has an even higher frequency than white light, so we often associate ultraviolet light with heat. With such a wide spectrum of light and wavelengths, plants have quite a few choices of how to get their light. The ingenious strategy plants have is that they've increased the potential of light they can absorb for photosynthesis by containing several different color pigments in their chloroplast. So now, with such a wide variety of light-absorbing pigments, plants have increased their probability for energy. This goes back to seasons. In fall, the sun rises later and sets earlier. There's less sunlight during the day. So plant cells don't need to make as much chlorophyll because chlorophyll picks up the wavelengths that are absent more often during fall because it's so dark all the time. Seasonal color change isn't just for show. It's strategic. It's based on the photolight spectra and the different types of pigments and colors they convey due to their bond lengths and wavelength absorption. Chemistry, physics, biology are all topics that twist together in this, and I might not think about anthocyanins every time I look at a leaf, but that curiosity within me has finally been satisfied, and I feel like I can appreciate the intricacy of our world all the more fully.